So it's James Robards, who's a colleague within the National Centre for Research Methods, and he's going to focus on a particular feature which comes up in a lot of anonymisation issues. We've had it this morning. We were talking about location data, and that's geography. Geography is actually a really significant variable in terms of identifiability. So James is going to talk about an interesting technique for dealing with that.
Thanks, Mark. So today I'm going to be talking about automated zone design and how we can use this in relation to anonymisation. So just to give a brief overview of what I'm going to be talking about, I'm going to discuss automated zone design, how this has come about, why it's used, how this has been used in the past, and then I'm going to talk about some of the new forms of data which are becoming available and the particular relevance of the technique to that, and how we have some initial results from our work using a synthetic test data set. So first of all, what are zones? What do we mean when we talk about zones? Well, we're just talking about geographical space, and often these are used in terms of polygons, and it can just be thought of as areas on a map. So typically these could be regions, local authorities, or things like mesh blocks for census outputs, or even postcode areas. And zone design is where we're starting to think about the locational information which we have on individuals in relation to disclosure. And something like an individual census record, of course, is potentially identifiable. Now, of course, there are a number of different options when you're dealing with such data. The standard approach is normally to aggregate over geographical areas, so you're meeting a minimum level of comfort for say, a one-off release of aggregated data. And then we've also got other techniques which can be used alongside that. For example, just record swapping or collapsing classes further. So if we think about just grouping up age and so on, and having other inbuilt sort of minimum thresholds in the data processing phase, which we might work through with a data set. So focusing much more on the kind of design element now of our zone design approach, really we have to think much more about these blocks and the number, the size and the purpose of these and how we're using them. So of course, depending on our blocks which we create, there might be differing results and associations which are drawn in our analyses. And some of you may have heard of the modifiable areal unit problem, and this sort of comprises both of what can be thought of as scale and aggregation problems. And really crucial is the choice of the number and the configuration of zones which you work through when you're designing a sort of solution. So thinking about a sort of schematic of what a census disclosure protection model could be thought of as being, we have our sort of processing, our collection of census data here, held in a database, and then that's released in sort of two key ways really. So we've got a secure access laboratory through which a individual level data set of some sort which might be made available for a group of research users who have special permissions to access that, but where the outputs are very carefully vetted. And then we also have the larger scale open outputs which would move through a sort of pre-production phase. So what I really want to point out here are that there are disclosure design decisions which are being made at each point before and after this processing of the data. And that's depending on the release and the user in particular, which we see over on this side here. So one example which is nice is the 2011 census output areas, which were a design where the mean population size was a target of 325, and then there were specific requirements in relation to the number of individuals and the number of households which must be within that zonation. And then the other criteria which were applied for this design were that it should match as far as possible to unit postcodes, which were an input as part of this processing, and then controls over the shape and the homogeneity. And then these were subsequently used for the publication of small area census statistics. So just running through the build-up of these. So we have our individual households here with a polygon around them. And of course they're nested within postcode areas, which are shown with the black line. So there are our postcode areas. So our first step is to dissolve those boundaries between address polygons which have the same postcodes. So these were our addresses, and then these were our postcode blocks. So our first initial random aggregation of the building blocks into a potential solution arrives at this setup where we've got our blue blocks which have all been combined to form one solution. We've got the green grouping here and the yellow grouping forming a third set. But then we can go on to choose a block at random. The tool just moves through, the algorithm which is created moves through to look at candidates for swapping into a different tract. So then it will make the swap and it will look at the impact of that on the overall solution. So our overall targets, how does it compare? What's the result of making that change? And then based on that, if there's not an improvement, then we can just go back to the previous configuration and take that forwards. And then we pick another one and we look at the potential swap of that. And then that's better, so we just keep that and we look at the next swap. And we can just go on and on like this, looking for the solutions which are giving us our best overall targets. And so this type of approach leads to these census geographies, like these, I think they're lower layer super output areas for London, and these maps that we see with census data from 2011. So what about if we look at a data file which is in a secure access laboratory, so like a virtual microdata laboratory, as is often as it's called. So we've got our linked individual records, and we've got potentially, they're potentially identifiable with the characteristics. So what we might do is we would just use large geographical areas which we're comfortable with, and then we might use some other area codes or classifications which we're comfortable with. The researcher works with those within the secure setting, and then any outputs, publications, tables are all cleared before being released. So the default sort of policy for using data in this kind of situation and for the administrative data research networks projects are where typically a lower layer super output area is being used with an average population of about 1,500 individuals, and this is as of the 2011 census. But of course our lower layer super output areas were generated from an automated zone design solution to meet that required level of comfort. So considering this new kind of environment which we're moving towards, where we're working with more and more linked data and data coming from a range of different providers, what about different zonations based on the requirements from those providers? So our new model might start to look something like this, where we have our data providers over here, who are providing data into a secure access laboratory, or where there's some form of linkage and then the data is input into that environment. And then we have disclosure design decisions, again, before and after this secure access environment. We have our analysis data in this location, and then we have vetted outputs, which are coming out of the other side. So we've got a growth and a desire to make better use of administrative data, and linkage of data is particularly important because some of the administrative records can be quite sort of domain specific and attribute poor. So the linkage is really important in relation to the domains and the location. And really we've seen widespread investment in the access to such data. And as so many of the speakers here today have said, there's so much potential from this type of data from the investment. So our specific project is looking at the utility of automated zone design for new forms of linked and administrative data, where we can start to create zones where there's sufficient information on the building blocks for the researchers and for their research to proceed, yet the locations of the individuals are protected and we're meeting the sort of minimum standards by the data set by the data providers. So in order to work through this, we've been using a synthetic data set which we've created, which we think will be useful for this and also for future studies in this area. One further kind of aspect which we're keen to have a dialogue on is about the process leading to the creation of the zones and the degree to which that is shared with the researcher, so that they can understand how those geographies were created and what they're using in their analyses. So such a situation would be where a data set is made available here, and then the researcher is working within this secure environment. And so for our specific example, we have a synthetic population from the 2011 census, and we have synthetic household locations which we've created also from other census data, and putting those together we're creating a synthetic data set with a high data volume and attribute detail. So as I was saying, our synthetic household locations come from 2011 census data, and to that we're also adding index of multiple deprivation data from 2015, and then we're working with postcode Thiessen polygons and also adding in data on access to general practitioners in Southampton. We're also adding in Environment Agency recorded flood outline data because we're aware of interest in working in this area, and so together we're forming a data set which has many of the properties of the linked data which is starting to become available. So to give an idea of the type of data set we have, well, we've got just under 100,000 households in Southampton, 45 GP locations, and then these are the counts for the other for the standard census geographies which are in use. Then we have about 5,000 postcodes which are our building blocks for our design solutions which we work through. So to give an idea of households, this is our map of households in Southampton after having worked through this process. So those of you who know the city, we've got one of the rivers here, the other river coming down here, and then the common in the centre of the city there. So we've used other 2011 census data in order to create these household locations, only putting them in areas which are populated. So we can map out our postcodes and our general practitioners, with our blue dots being our GP locations. And then we add in also our flood data. So these are Environment Agency recorded flood polygon locations. So to give an example of when we start to add this data together and what it starts to show us, this is one small locality within the city. So we've got these households which have information on whether or not they're in the flood area, what type of flood event it was, when the flood event occurred. We've got the distance to the GP as well. So we're starting to build up a lot of information about these individuals and their locality where they are. Added to that, we've got our index of multiple deprivation data as well. So we've got our IMD deciles. So we've got lots and lots of information for each of our households now, which we're working with. So now I'll show a range of zonations based on differing target populations which we set. So we start off with our postcode building blocks like this, and then we have a range of targets. So this is a zonation based on a target population of 250 people with a minimum threshold of 100, and it arrives at this zonation. And then we gradually increase those where we have a target population of 750 and then 1,500, and you can start to see that our number of blocks decreases greatly, especially between those two. And we can also compare that with the standard census geography, the LSOA geography, which, as I said, also has a target of 1,500. So you can get an idea of the same number of blocks, but a very different geography, even without the river being shown there. And then the largest zonation which we have here is where we've got a target of 3,000. And so, of course, really what we'd also be looking at as outputs would be a series of tables, perhaps. So here we've got our number of units for each of the zonations, the average population, and then we've got our minimum threshold, which was set for the tool to work through. So here we can also start to see some of the other linked data which we've added in and how that varies by the different zonations. So we have our mean distance to a GP for each zone, and we also have the same for each postcode. And then we've got our distance to GP IMD score over here in this column. So what our work is doing really is highlighting the sort of pervasive nature of geographical units and the influence really that they have over analyses. Currently, we're adding in synthetic population data to the sort of households, and through this we're going to look more at the sort of disclosure control aspect in our next study. As I perhaps have already kind of emphasised today, really we're very keen to understand how we can maximise the protection for the data provider with this technique, and also ensure that the data utility remains there for the researcher. So we think that this type of tool and approach has a real value for both of those parties. There's also a sort of question mark around transparency and the degree to which you can quantify the solution and provide that information to the researcher. And that's something that we're sort of keen to debate and hear people's thoughts on. And I think I've probably highlighted that there's a wider applicability to all sorts of administrative and linked data out there.
Thanks, James. Questions? Rainer.
Can you explain again what's the difference between your approach and other microaggregation approaches?
I would say that it's the tool and what it can take into account in its in the way in which it's building up these aggregations. The range of parameters is quite it's yeah, there are quite a lot of parameters you can feed in, and that has increased quite a lot over the years.
But the base mathematical idea is simply you have some units and then you increase the spatial tessellation until the spatial tessellation contains enough units.
Yeah, that's right.
The core of many microaggregation techniques. Actually, that's the description of a microaggregation.
Yeah, there are any number of ways of doing that, I guess. But perhaps I haven't really been able to run through exactly what the tool includes, because it has there are a lot of parameters you can include in the tool when you're specifying what you want it to do. I guess I would say that the specification in terms of what you can actually include. What I presented today are quite a sort of, I guess, a sort of more basic set of zonations, just to sort of put the idea across, rather than to outline the full set of parameters.
I mean, it's partly as well that you can plug in utility drivers to your aggregations, I think. So you have a set of contextual properties that you want to maintain about
Exactly.
what the areas look like. So it's not simply a mathematical problem.
No, so you can include connectiveness, and you can take into account islands, other geographies you can include.
Homogeneity.
That's right, exactly.
Yeah, there's a whole set of things that you can take into account. At least that was my understanding. Anyway. So, hi.
Excuse me, and do you have some data on what are the gains obtained compared to other methods?
On the results relative to other methods?
Yeah.
No, I don't.
And in terms of drawbacks, so for instance, if for instance you have one messy data set, so is it makes it better or worse than if you do it otherwise?
With a messy data set?
Yeah.
Can you give me some kind of example?
So for instance, if you have like one of the data sets, for instance, too old, so you have much more. So, for instance, you have much different data for the GP practices or something else like this. So you have half of the households not covered or something else like this, and then you link it.
Okay.
And then you try to apply your technique results, or you can just look without this. So
Yeah, it's an interesting question. I guess we've tended to feed in quite good data to start with, because we've been quite fortunate with the input data, but that's an interesting thing to think about, certainly.
Any other questions?
Hi, Jim. Thank you for the nice presentation. I hope my question is not a repeated question. Previously, you have shown a very complicated metric. I just wonder, how do you balance the maximize of the protection and data fidelity, as well as the efficiency of the algorithm?
Okay. So I guess I guess I think about two separate things there, really. So first of all, you were talking about the minimum thresholds and so on. So they would be set based on some kind of policy, I guess, from a data provider's perspective on what their specific requirements are. In terms of the processing and the algorithm, I've never had any problems in terms of the duration of time that it's taken to run. Obviously, in this specific example, I'm just talking about Southampton. We actually have broadened this out now to include more rural areas, so to include more of a balanced set of geographies in our analyses. And there's not really a massive problem with running the analyses at that scale. I think it obviously, as you start to move up, if you wanted to do it at a national level, then that would take some time to run. But no, it's not a problem.
Thank you.
Time for one more.
Just a comment, James, that in your Southampton example, there are two or three sort of quite physical boundaries, like the avenue.
Yeah.
A lot of your zones were across the avenues, that line that goes straight down.
Yeah, so the
other one.
the avenue is sort of down here.
Yes,
Right, this-
it's actually on one of the other ones.
Yep, it's on that one. That's the LSOA. Yeah.
And yet a lot of your zones seem to cover both. And yet one of the criticisms that we did have from 2001 from some local authorities were that areas didn't mean anything. It was partly Mark's comment about homogeneity, that you had some people on one side were council estate and the other side were quite a well-to-do area. So presumably the tool can take account of physical boundary like is that the Itchen or the test, the river.
Yeah, that's the Itchen.
The Itchen, yeah.
That's right, and I guess that comes back to this being quite a simple zonation at this moment in time, I guess. Whereas with this LSOA zonation, that road through the centre there, which is creating this line here, would have been taken into account, wouldn't it? So yeah, thank you. That's a really valuable point.
Okay, well, thanks very much to all our speakers for this afternoon.